Okay, in this video, we're going to solve using the Laplace transform. It's not really maybe the most direct way to solve this, but it's an exercise, and we're going to use some formulas here for this problem. One is, we'll start off with, is Laplace transform of y prime is sy of s minus y of 0, and Laplace transform of y double prime is s squared y of s minus sy0 minus y prime is 0. So capital Y is the Laplace transform of little y, and these little y here is y of 0, y prime is 0. Those are the initial conditions. And then we also have the formula that Laplace transform of e to the at is 1 over s minus a. So if I apply the Laplace transform to both sides of this, I'll get something. I'll just keep working on, I'll work away on this and get something. So, okay, so we use linearity. So we have Ly double prime minus 4Ly prime plus 5Ly equals, on the right hand, 4 over s minus 3. Because the Laplace transform of e to the 3t is 1 over s minus 3. So we're going to get s squared y minus sy of 0 minus y prime of 0 minus 4 sy minus y of 0 plus 5y equals 4 over s minus 3. So this is going to give s squared y minus sy of 0 is 2 minus y prime of 0 is 7 minus 4 sy minus 2 plus 5y equals 4 over s minus 3. So I'll have s squared y. I'm going to group the terms that have y, and then I'll group the terms that don't have y. So I'll get s squared minus 4s plus 5y equals, so negative 7 plus 8 is 1. So this will make 2s minus 1 plus 4 over s minus 3. And what I need to do is actually, I need to write this all as one fraction on the right-hand side so that I can do the work I need to do here. So that's going to give us 2s squared, okay, minus 7s plus 3 over s minus 3 plus 4 over s minus 3. And that little step there that I did rather quickly is such an important piece to get the problems right. And you can see, well, this is why someone would do it on the computer, because would you really, if this was something that was so important, you want to have something more, you want to make sure about your answer. So, all right, and so that I'm going to get y is equal to 2s squared minus 7s plus 7 over s minus 3, s squared minus 4s plus 5. This part here is irreducible. And we're going to use partial fractions to write this as a over the linear part, a over s plus minus 3 plus bs plus c over the nonlinear part, s squared minus 4s plus 5. And so if I clear the fraction, I'll get 2s squared minus 7s plus 7 equals a s squared minus 4s plus 5 plus bs plus c s minus 3. And what we do is you put s equals 3 to kill that s minus 3. It's a convenient number. Put in s equals 3 and you get 2, 3 squared minus 2 times 3 plus 7 equals a. 3 squared minus 4 times 3 plus 5. And so the s minus 3, that's 3 minus 3, just kills everything over there. That makes 0. So this makes 2 times 9 is 18, minus 7 times 3, so it's 18 minus 21. Oh well. I mean, it's so common for me to make mistakes, so why don't I try to show a bunch of work here and make sure I don't make a mistake. So I sort of think I did, because I thought I was going to get oh, maybe it's going to be all right. Okay, I got an integer, sort of what I thought I was going to get. Okay, so now I got a is equal to 2, and what you need to do is you need to use that a here. So 2s squared minus 7s plus 7 equals 2s squared minus 4s plus 5 plus bs plus c s minus 3. Now what I'm going to do is put s equals 0. That's going to kill this bs term. It's going to kill the b term. See, now we only have b and c to work with. I kill the term that has b. So but 0 is, putting s to 0 makes everything that has s a 0. So let's go sort of fast for that. So 7 equals 10 minus 3c. So negative 3 equals negative 3c. So c is equal to 1. Okay, knock that one off. All right. So copy down the equation again. And then I'll just put in another number. We ran out of convenient numbers, so I can just go ahead and put in, you can put in 1. But there's another way that's actually more quicker, is we have 2s, see you have this, didn't mean to erase. I have 2s squared plus, this is going to be bs times s, so it's 2s squared plus bs squared equals 2s squared. So that means bs squared is going to equal 0, which means b is equal to 0. But anyway, that's going to be faster than the way I'm going to do it. So why don't I just stick with that? I don't know. It was sort of fast when I said it out loud, but after I write it down, it might be not as fast. No. Oh yeah, okay. I thought I made a mistake, but it looks all right. Okay. All right. So we get that just by putting in values for s. Now, again, what I'm saying is that y is equal to a over s minus 3 plus bs plus c over s squared plus, or minus 4s. It's these little things copying down that are so important, plus 5. So this is going to be 2 over s minus 3 plus, well, b is 0, so it's just going to be 1 over s squared minus 4s plus 5. Now, again, this is irreducible. So that means we have to complete the square, which, we did that in pre-calc, and so I don't know. Seems like we might be able to remember that. 4 divided by 2 and square it. So I get plus 4 minus 4 plus 5. So I add the 4, subtract the 4. So I get y. Why would I do that? Because this makes y equals 2 over s minus 3 plus 1 over s minus 2 squared plus 1. I'm going to use formulas. Laplace transform of e to the at is 1 over s minus a. So that's used for this one here. Laplace transform of e to the at sine of bt is b over s minus a squared plus b squared. I use that over here where b is 1 and then a is 2. So I get little y is equal to 2 e to the 3t plus e to the 2t sine t. And, one of the ways you can check it right off is to look at when I put in t equals 0, I get 2. Isn't that our initial condition? So putting y equals 0 gives 2. If I take a derivative here, then taking the derivative, you have to sort of spend some time looking at it. But I take the derivative, 2e to the 3t, and you get 6e to the 3t. When you put in t equals 0, you get 6. Taking this derivative, you'll get 2e to the 2t sine t by putting in sine of 0, 0. And then plus e to the 2t cosine t, and then putting in 0, you get 1. So it does satisfy the initial conditions. And then you can further take two derivatives, plug in, and make sure it satisfies the differential equation. But that's a lot of stuff. Okay, that's it.